Hi, my name is Ariya Hidayat. I'm a software engineer working at Qt Software Nokia. In the next 15 minutes, I'll be talking about beautiful and blazing fast graphics with Qt. A little bit about myself. I just finished my PhD in electrical engineering, and earlier this year I decided to join Trolltech, now known as the Qt Software unit in Nokia. In Qt Software, I work in the graphics team, working on high-level graphics. I'm also an open source developer. In the last 7-8 years, I contribute mainly to KDE. So the agenda for my talk will be as follows. I'll start with an overview, and then we'll take a look at QTransform and some of the QImage pixel manipulation. And then we will continue with some effects that can be achieved by using QPainter composition modes. And I will briefly touch the color space topic and as well OpenGL. And then I'll show you some tricks with image scaling, and finally a bit about widget handling and some new features in Qt 4.5. So the objective of this talk or this presentation is for you to have some ideas or some tips, some tricks, and inspiration so that you can make your application much more beautiful. In a simpler term, if you have those ingredients, fresh ingredients, you should be able to transform this into a candlelight dinner. So the analog will be you take all the graphics related classes and turn it and pack it together so you can have a beautiful application. Of course, just like when you read the cookbook, you will not be suddenly a chef. In this talk, instead of only talking about the graphics related classes, I'll present some examples as well. So we'll have a look at the code or the ideas behind those examples. So the title of the talk mentions something about blazing fast. The question is, of course, how to do that? Well, the most important point is that you have to avoid any slow operation, because any slow operation will make your application slower, which means that it won't be fast. Now, the real problem is many developers just assume that some part of the application is slow or some other part is slow. But in order to really justify the bottleneck, you need to use some tools. So my suggestion is to use the right tools for profiling or for finding out where the bottleneck in your application is. On Linux, you might use call grind module in file grind. And on Mac OS X, there's Shark, which is available as part of the Mac OS X developer tools. So using both these tools or one of them, you can quickly point out where your application spends its time most. And then, of course, try to make it faster there. So that's the first hint. Now let's just start with some interesting examples. You create an application. And of course, if the application is something about something visually available to the user, then somehow you need to present a screenshot. This is just normal. This is very human. If a user checks a new application, most likely he sees first whether the screenshot is attractive or not. So here, for example, on this screen, I present a screenshot of Plasma, the new desktop in KDE 4. There are two screenshots here, on the left side, on the right side. And yeah, they have rich color, they have interesting pictures here. Everything looks perfect. Now, the challenge is how can we make this much more beautiful without sacrificing any performance? So what I'm going to do is to put these two screenshots in a new little tool called Screenshot Composer. So here you see again those pictures that I just loaded in the Screenshot Composer. Now, let's have a look here. These two pictures are great, but they're a little bit boring. I mean, why don't we add some effects so that it feels much more natural? The question is, what kind of effect? Let's try with some reflection. Here I check the box here, which says reflection, and all of a sudden you'll see the reflected image of this screenshot right there. Well, now we have the reflection. However, the reflection doesn't look really natural. We can make it a bit better by applying some gradients here. So instead of just like this, I apply some gradients here so that you can see the image fades out as it goes down there. This looks a bit better now. Next, what we can do to improve it is to make the mirror image here, the reflections, less strong compared to the screenshot that we want to display. So for this we can apply some transparency. I change the opacity slider here, and you can see that out of sudden the reflection is just like reflection. It's not as strong as the original image. So when you see these images with its reflection, you might get the impression this is just like a, say, big stone standing on a frozen lake, for example, or on the water in a lake, because it has some sort of reflection. Now, when you see this, you can have a three-dimensional feeling because you see the reflection. But let's make it a bit more three-dimensional by changing the location or changing the position of these images. So what I can do is just to rotate the image a bit. I mean, I move the slider here. Say, let's make it something like this. So the image is a bit tilted, the one on the right side. And of course, you can adjust the same, the angle for the left images as well. So you can have something like this. And there are some slider here that allows you to, say, modify the distance here so that you can find the optimum setting or make it larger or smaller to give the feeling that both images are not of the same distance. So that's basically what we can do to those screenshots. So this is the end result, which is hopefully a bit less boring than the original one. And let's have a look at the ideas and tricks that allows us to convert this boring screenshot into something which is much more attractive. First, let's start with the reflection. So how to create reflection? So if you see the picture on the left side here and on the right side here, if you compare both, then you can see that the one on the right side is just basically this one reflected vertically. So you don't need to do it by yourself because fortunately QImage has a function called QImage mirror that exactly does that thing. So if you call that function on this image, you'll get this one. So far, so easy. Now, as I said before, if the reflection must look a bit more natural, then of course you try to make it fades out here. Again, in Qt we can use the class QLinearGradient, and then you create a linear gradient that goes from top to bottom and use this as the alpha channel here. In effect, it makes the image very transparent at the bottom, a bit transparent in the middle, and not transparent at all at the top of the image, which is exactly the effect that you want to achieve. Now you have the alpha channel. We can try to say reduce the transparency of the image. So if you compare here on the left side, on the right side, the reflection is more transparent than the one on the left side. So the trick to do that is, again, we just use set opacity function in the QPainter class to do that. So here the opacity will be 1. On the right side the opacity will be less than 1. Finally, we have to use QTransform. QTransform is a class that can be used to achieve, for example, scaling. So if you have this image, you can make it smaller. Of course, you can make it bigger as well. That depends on the scale factor. You can do it also to rotate the image. So here I show an example. They are of the same size, but the one on the right side is a bit rotated. But of course, the most useful things for our purpose here is QTransform can achieve perspective transformation, which means that if you have that kind of image, you can rotate it in the vertical axis here, so it appears something like this. So using the combination of image, linear gradient, painter opacity, and transformation, we can achieve that result. So, speaking about reflection, you can use it not only for creating screenshot. For example, if you have some color pie, something like this. This pie displays different colors. You can also have a reflection underneath here. This reflection has nothing to do with the colors, but it gives the impression that, oh, this pie is really three-dimensional and sits on top of something, frozen lake or whatever. In order to make the reflection much more natural, you can also apply some blurring. So if you see here, this is the image, the same one as in the previous slide. But if I zoom in here, then you can see that the reflection is like this. You can see at the border, it does not just go from, say, blue to white directly, but you can see that this side is a bit blurry. It's not sharp like this, for example. This gives a feeling that the reflection is much more natural. In order to achieve this kind of blur effect, you might want to manipulate the pixels on the image and then apply, say, certain convolution and so on. So let's talk a bit about pixel manipulation with QImage. So QImage is a very useful class in Qt. QImage stores the pixels of the image in a hardware-independent manner. So if you work with QImage, you can work with the same code on X11, Windows, or Mac OS X, or even embedded, all the platforms that Qt supports. Please note this difference because QPixMap is Windows system dependent. So if you work with QPixMap, you might need to modify your code if your application works on X11 and Windows, for example. But with QImage, you can use essentially the same code for doing the pixel manipulation. So important two functions of QImage is pixel and setPixell. So as you might guess, pixel gets the color of the pixel at certain location, denoted here by X and Y. And setPixell sets the color for the pixel on that location. So you have to pass the color information here, which is in the form of RGB. So if this is our image, you can see there are a lot of pixels here. So as long as you know the coordinates, you can modify this, the pixels on this image. Of course, pixels and setPixel are good, but we're talking about something blazing fast. So instead of doing the calls to pixel and setPixel, we can optimize the code a bit. The trick is that there are other two functions in QImage, namely bits and scanline. So if this is our image, it stores in memory as scanline. So the first location in the memory will be the pixel on the top left corner, then it goes that direction and going to the next scanline and so on until the last pixel here. So if you want to get the top left pixels, then you can use bits. This returns a pointer, which means that you can use this pointer to iterate through all the pixels in this image. As long as you know the width and the height, of course, which you should know anyway. If using bits is a bit cumbersome, then you can use also scanline, because scanline here takes the parameter I, which is the row here from top. So if you call scanline with say 5, then it returns the pointer to the color of the pixel, the first pixel at the 5th row. So this can be useful, because then if you have a pixel in the middle here that you want to modify, or if you want to width the color of that pixel, then you can use scanline to go there and then just increase the pointer until you reach the pixel that you want. So this way it's faster, you don't need to call setPixel and pixel. But you have to be careful with this technique. The problem is there are two different versions of QImage bits. The one that is a constant function and returns a constant pointer, and the other one which just returns a pointer. So the problem with this is because QImage is using the typical Qt implicit sharing. So if you pass QImage one, for example, to another function, you don't really create a copy of the pixels data. Instead, you just pass the reference, actually. So this is handled by Qt internally, you don't need to care for that. But in some cases, for example, if you ask for a bit that is not a const, then Qt will not know whether you want to modify that particular instance of QImage or you want to modify the pixel data that shared across all different QImage instances. So the end effect is that it will do a detach, which means that Qt might potentially create a copy of everything here. So you have to be careful with this, because it means that the operation first will be slow, because you don't operate on this image that you want to do, but you operate on the copy. So first the copy operation will slow it down, and second you might not modify something that you want to do. With the const function, however, it is guaranteed that you will touch only the image that passed to the bits function. So if you width the pixels using the bits function, please use the const version of bits. Now, using the bits and scanline, there's an interesting effects that you can see, the so-called pixel shifting. So, say this image consists of many scan lines, and if you just move the scan lines on the this image horizontally and vertically, you can get some interesting effect that I'm going to show in a few seconds. So here is the image. I can enlarge the amplitude here and make it faster. And you can see that this static image is now transformed into something that is moving. And you have the feeling that this is something like if you go under the water, in the sea, for example. So basically what the examples or the application here doing is it takes a scan line and then shifts it horizontally and do the same also vertically. if you ever remember the old game Quake, the first one, Quake used the same technique. When you go under the water and all of a sudden all the scenes is just distorted periodically like this. So where was I? So that's one of the use of straight pixel manipulation with QImage. Something that you might notice is that there are different formats for image. You can use ARGB32. ARGB stands for alpha, red, blue, and green. Each comprised of a byte, which means that the whole thing will be 32 bits, hence the name. And there's also a format ARGB32 pre-multiplied. The question is now, what's different between this? So the difference is visible only if the color of a pixel has an alpha channel, or it's not opaque, it's transparent. For example, take a look at the typical color here. So this color has the components as those, so RGB are just like that, and the alpha is 128, which roughly means that this color is 50% transparent, because 1 byte maximum is 255. So the R and G and B are multiplied with the alpha channel in the pre-multiplied format, as you might guess from the name. So the alpha channel has the same value. However, the R, G, and B here are half compared to those. So, for example, instead of 212, the G here is 106, because 212 divided by 2 equals 106. Now, the question is, why do we need this kind of different formats? We can just use as well ARGB 32. The problem is, or the question is that when you have an image with alpha channel and you want to blend it on top of another image, then the formula will be like this. R here is the R components of the pixel, of the color. So you have to say multiply the components with the alpha channel of the color. Of course, you can do this when you're doing the alpha blending, but it is much more efficient if you do it beforehand. So if we don't have any multiplication here, just like this, then we save one multiplication for every alpha blending operation, which means that the whole alpha blending will be much faster. So this one is for ARGB32 and this one for ARGB32 pre-multiplied. So Qt doesn't need to multiply the red components with alpha channel anymore, because it's already pre-multiplied. So that's the idea. So whenever possible, of course not in all cases, but whenever possible, try to use the ARGB32 pre-multiplied format. That will make your application faster. Now, another interesting thing that might happen to your application is just you optimize a lot and then you bring it to some other platform. Out of sudden, it's just very slow. Then you do some debugging and then you find out that, oh, the problem is very slow is because the target display here is like 16-bit. So you have a 32-bit image here, 32-bit pixmap, and you want to paint to this display, for example, embedded device display, which has only 16-bit. In this case, Qt needs to perform 32-bit to 16-bit color. It's not a cheap operation, which means that every time you try to display this image, of course you will have problem, because Qt will do the conversion for every single pixels, and that is expensive. So another thing that you can do is, if you know that your target display is 16-bit, try to work with 16-bit image. Now, of course, it's not a is not that easy, because 32-bit image has the advantage that, as I've said before, each of the color components is in 1 byte. So the alpha, red, green, and blue, each of them is 1 byte, which means if you multiply it, if you shift, and so on and so on, so it's easier to do. However, in 16-bit, there are different formats, like for example 555, which means that red, green, and blue each is 5-bit, and yeah, you have to do a lot of bit masking, bit shifting, and so on just to get the green component, for example. So on one hand, 16-bit image could be faster if you want to display it straight to the display here, assuming that display is also 16-bit. On the other hand, when you manipulate the pixel in 16-bit image, it could be slower than doing it in 32-bit. So there's nothing you can do here except to try both and then profile your application and see which one is the fastest. You can try to keep all the operation in 32-bit and on the last moment convert it to 16-bit, or you can try to work with 16-bit image directly. Now let's move on to the other topic. Since it's about blazing fast graphics, so I'm going to show you another demonstration. So here is, as you might see, some covers of some book, and if I move around, then you will have those kind of effect. So you can see that it's quite smooth. If I move it that way, it's quite fast. Or I can also just flip over the covers just like that. So there are several techniques that are employed in this example application to make it very fast. First of all, there's so-called lazy loading. Let me launch the application again so that you get the feeling of how lazy loading works. So now I have 1, 2, 3, 4 book covers visible on my screen here. But if suddenly I try to move quite fast, you can see that it's black now. So lazy loading means that this application doesn't try to load all the book covers from somewhere, say from a disk, from a database, from the internet, but instead it loads right when you need it. So if I go there, they're all blacks, and then it becomes visible, the book cover. See it here? So just right when the user is there, then the program tries to load it from the disk. First, it saves a lot of memory because you don't need to keep everything in memory. Second, because you load it only on demand, it means that the application starts quite fast because it doesn't need to say read, convert, and load all those 1,000 files when you start the application. So that's the first trick. Another trick here is the so-called ray casting. Ray casting is a simplified version of ray tracing. Basically, you just cast a ray out of your eyes in all directions and see where it hits. So in this case, it will hit the cover of these books sooner or later. And then we find the distance and then try to scale that cover to that distance. That's important, but let's have a look first at how we can speed up the ray casting processes. So if you see here, this is the cover, you see the reflection here, all with the blur effect, just like what I mentioned before. That's nice, but when you render it real time, you don't want to create this cover, this reflection with all this linear gradient and opacity and blur effect on the fly because it will be just expensive. So what you can do is you just store it. So at the beginning, when you launch the application for the first time, you have this cover, just create the reflection when you load it, not when you display it. And then save this reflection together with the image. So in this application, I call the whole thing here, the cover with the reflection, as surface. So that's one of the tricks. Pre-render as much as possible. If it is possible to create the reflection before you display it, then go ahead and create it and store it somewhere. There's a price that you pay, because then you also need some memory space just for the reflection. And second is, well, you can do the scaling by yourself. So this needs some explanation. But if you have a look at the picture on the right side here, then you might think, oh, we can just use QTransform for that. Why? That's true. You can use QTransform, but you can also do it yourself. So what this application does is basically take a column here, which consists a lot of pixels, and then scale it. So the column is from that point to that point. However, the height of this column is depending on the distance from this column to the user eyes. So what you have to do is basically go through each column here from left to right and then scale it appropriately. So the first one will be, of course, smaller than the last one. That way you can achieve an effect of perspective transformation. And this is usually fast enough if, say, the images are small and you don't really care for the quality. I mean, QTransform can display a perspectively transformed image with bilinear filtering, for example. In this case, you just want to animate something, so you don't really care for quality. So you just try to scale it and then try to do it as fast as possible. So that's another trick. Do it yourself if you see that the classes or the operation that Qt does for you is not as fast as you want. It's always possible to do it yourself. And of course, there's another thing. If you want to scale this column, basically you just go through all pixels in these columns and then of course put it on the screen. The problem here is, just like I mentioned before, QImage is stored from the top left, goes to the right, and then the next scan line goes to the right, and so on until the last pixel on the bottom right corner. So if you take a column in the QImage, then if you have this position and you jump to that position, the amount of jumps here is big. It depends on the size of the image, because from this to the next scan line is already several hundred bytes, next scan line several hundred bytes again, and so on and so on. So then the end effect is, if you jump from here to there, you need it because you want to access the pixel in this column. Then you might make a jump several kilobytes. Seems not a problem. However, if you look at the modern processor has a cache where it can store a small amount of data, any data from the memory in the cache, and accessing it will be extremely fast because it doesn't need to go through the bus of the main memory. So what we can do here is we transpose the image. So instead of accessing this column vertically, first you rotate the image 90 degrees, and this column now becomes a row or a scan line. The advantage of this is that if you move from this to the next pixels, it's just 4 bytes away if the image is in ARGB format. So if you jump from this to that pixel, it's actually probably, say, 100 bytes away or 200 bytes away, which means that as you traverse along these pixels on this row, transform from that column, the pixels that you want to access are likely still to be in the processor cache, which means that doing that is faster than doing this. Of course, this is better if you monitor it. So if you use, say, for example, cache grind, one of the file grind module, to verify that, yes, doing this touch the bus of the memory only once a while compared to this. So if your processor, if your target device has a cache, try to optimize it, try to adjust your image processing so that you can take benefit of that cache as well. I mean, going from this to this is requiring only a transpose operation one time at the beginning, so the cost for that will not matter a lot. And after that, you can do everything here just like you do it here, only horizontally instead of vertical. Now let's touch another subject, namely the composition modes. So composition defines how an image is composite into another image. So if you have an image and you have a widget, for example, if you paint the image on the widget, then the composition modes for that painting defines the end result. So there are several composition modes that are supported by QPainter, starting from source, which means that source displays the replace the target, or destination, source over, often called alpha blending, destination over source, and so on and so on. I will not bore you with the details of these composition modes. You can take a look at the Qt documentation on these modes. But there are also some interesting composition modes, some advanced composition modes. So like, for example, multiply screen overlay. That's what I'm going to show you. So this is an example in Qt demo. So you can just run the Qt demo program and go to demonstration and composition modes, and you'll find the screen. I will briefly describe the three interesting composition modes here. First, multiply. So this is the big image is in my destination. The small circle here is my source. So if you multiply the green source here with that background, this is the result. As you can see, this part of the image becomes a little bit greenish. You can also do the same with screen. Well, it's a similar effect, but it's very light, so it's not dark like this anymore. Or you can use overlay. So the effect will be some sort of combination between multiply and screen. The question is now, what's the use of all these three composition modes? You can have bloom effect by utilizing the composition modes. Let me launch the examples. We can close this. So the bloom effect is as follows. This is the original image, and this is the image after you apply bloom effect. So if I disable the checkbox here, then those images are equal. So you can see they are the same. So, but if I enable here, you can see here it's much brighter and have this kind of effect as if you're like in a dream or so. So the trick to achieve this is to blur the image and make it brighter, and then combine it with the original image with some interesting composition modes. So you can see here I have a choice for the composition mode: multiply, screen, and overlay. So this is the result if you do an overlay. I can do multiply, for example, and the effect will be darker. And you can change the opacity. So either it's very dark or very light. You can change also the amount of brightness that you want to put in the image, and you can make it more blurry or less blurry. That's for multiply. You can also use screen, which make everything very light, so something like this. Or you can also use multiply. So you can choose the composition mode that suit your need or achieve the effect that you want to do. There's also something like soft light, and there's also like hard light, lighten. For example, here you can see as if like, there's a fog here at the harbor. I mean, I can increase it extremely, and then you see that it's very foggy there. So bloom effect nowadays is used in many applications. For example, many games, many modern 3D games, for example, have those bloom effect. Let me just mention, for example, Rainbow Six Vegas, because the settings is in Vegas, a lot of casinos and so on, lightings. So bloom effect makes it much more realistic. And in films as well, for example, Elephant's Dream is using bloom effect to achieve an interesting effect, as if you're like in a dream. So that's about the bloom effect. So you can use composition modes here to combine the blur and brighten image with the original one and achieve that kind of effect. Another possible use for bloom effect for composition modes is to change an image, to change the color of an image. Let me launch the demo application for that. So say we have this is the original image, some berry with some leaves. I can make it grayscale, for example. So out of sudden the colors are gone, you can see only shades of grays there. But I can also color the image, colorize the image. For example, here it looks purple, but you can make it red if you want, just by changing the slider. Here is red, for example. You can make it blue, or you can make it green. Again, there are choices for composition modes here on the left side here. So you can use screen, everything looks really bright. You can also use overlay, not that bright. Or you can use multiply, which makes it as if it's taken at night. So what's the trick? So this is the original image. You can make it grayscale by using the function provided by QGray. So it takes color and then give you back the shades of the gray here. So you just need to do this for every pixel in this image. Then you get a grayscale version of that image. And then you can also colorize the image, Tint Effect, just like what I've demonstrated beforehand. So basically on top of this grayscale image, I draw a big rectangle with a color that you specify, and use the screen multiply or overlay composition mode when you draw that rectangle, that color rectangle. The effect is like that. So you change the image from this into something like that. Of course, you can tune the color there. It doesn't need to be green. So that's about QPainter composition mode. Since we're talking about colors, let's touch briefly the color space topic. So what I want to see is here there are two important color space. I mean, the one that you probably know already is the RGB, red, green, blue, but this one is something different. This is hue, saturation, and lightness, or hue, saturation, and value. So HSV is normally depicted in a cylinder or a pie, like this. So you have black color here at the bottom, and as you increase the value, the color becomes saturated, and you can see here like in a rainbow. It is a bit different, however, in HSL color space, where at the bottom you have complete black and on top you have complete white. Right now Qt only support HSV. Usually it is already sufficient for many use cases. However, HSL can be also useful if you want to, like, you have a color, you want to find the other color that have the biggest contrast. So here it's easier because if you have white, the contrast to white is black, and vice versa. If you have black, then you just take white as the most contrast color. So once a while, or in some use cases, you want to use HSL, or you want to get the HSL component of a color. How to do that, since HSV is the only one that is supported by Qt, besides RGB, of course. Well, here there's 5 lines of code that allows you to convert the HSV to HSL. So it's very simple. I decided to show this because apparently if you Google it, you cannot find anything related to that. Or if you have HSL and you want to convert back to HSV, then you can use the other function. It's also only 5 lines of code. So that's all about color. And OpenGL. So if people talk about fast graphics, usually they think about OpenGL. Good thing is that Qt supports OpenGL. We have something like QGL widget, which is the OpenGL version of QWidget. The painting system and so on is very similar. So if you want to accelerate your application, you can substitute your QWidget with QGL widget and it should just work. If you want to take a look at how it's implemented, you can see the examples OpenGL 2D painting. So the example will show some interesting animation where on the left side it's painted using the native method, for example X11 using the XLib, or using the OpenGL, and you can compare the results side by side. It is usually the same. It's supposed to be the same. But the painting using OpenGL will be, of course, faster. On the other hand, if you have a lot of widgets, if you don't do the painting by yourself, but you just use like Q combo box, Q buttons, and so on, but you want to use OpenGL, so because Q button has no idea about OpenGL and so on, how to do that? Well, one trick is to put all the widgets inside graphics view. So here I have like push button, text box, another push button, and so on. Here's some text, and here's some other text. And the whole application here is just one graphics view. So graphics view support OpenGL if you set the viewport to GL widget, which means that if you put your widgets on graphics view and the graphics view is using OpenGL, automatically all the painting for your widget will be hardware accelerated through OpenGL calls. The details of this can be read in the Qt Quarterly issue 26. Now, I mentioned before, to make your application fast, you have to avoid slow operation. This seems obvious, but on some cases you really do not know, or you really cannot figure out where that slow operation occurs, or how do that happen. The obvious example usually is the collision detection. Let's speak about items in graphics view. So if you have such a complicated item and you want to find out whether this collides with those other complicated items as well, so what you do is you call QPainter path intersect. So you perform an intersection between this path and this path. This gives a very accurate result, as you might expect. However, any path operations are expensive. That's why I put the title, Avoid Path Operations. So in this case, just if you move this a bit and then every single time you try to intersect it with the other item, it will be very expensive. Same goes for clipping. If you have those items and you have three small items here, and you just want to clip the painting of these three to be only inside this big item, then it needs to clip all those paths, which is also another expensive operation. So you really need to see your profiler and find out whether clipping or probably collision detection is the cause for the slow operation. There are some tricks, for example. If you want to do collision detection, on most cases it's possible just to do it with some approximation. For example, I have a rounded rectangle here, and I want to detect whether this rounded rectangle collides with a dark blue rectangle here. So if you want to do perfect collision detection, then you use the intersects item shape here, because then it checks whether this rectangle hits the shape of this item. That's fine, that's good, that's what you want to achieve usually. However, it's slow. So why don't we take any approximation? Let's take the bounding rectangle of this rounded rectangle. So the bounding rectangle is obviously rectangle, shown here in the dash lines. It's not the same as the rounded rectangle. However, it gives a very nice approximation. If you just want to detect whether this dark blue rectangle hits that one, you can as well use the bounding rec here. So you just use this function, but passing the intersects bounding rec. Of course, it won't be as accurate as this one, because you might hit the corner here, whereas in this case you don't hit anything. But if you can approximate it and you can live with that, then just go ahead and use it. And of course, you have to be careful when you use mouse. This seems strange, but if you move your mouse around on a graphics view, then it needs to find out whether some items are selectable or movable and so on. So it needs to perform all the path operation. So the trick here is, if you don't need any items to be selectable and movable, then set this both flags to false. That will increase the performance, because now graphics view doesn't need to bother to do any path operation with that item, because it's not movable and selectable anyway, so we can just ignore it. And important thing is that graphics view is designed for large number of items but static. So if you move items around, so there's some cloud here that you move there, in today's user interface, both in desktop and embedded, you see all these kind of effects. So items flying around in all directions. Every time you move the items, graphics view needs to adjust its index again. So that could be expensive. So if for a short period of time you need to move this to there, then you can temporarily call this function set item index method and use no index. So after the item is in a fixed position again, then you can return to use the BSP indexing. That usually speeds up the rendering. And of course, some related technique, if you don't need to do smooth painting, anti-aliased, then better to avoid that. Sometimes you do it by mistake. For example, let's have a look at the screenshot here that I already enlarged. You have combo box here with some drop down arrow, and if I zoom it, it looks like this. First, it is not sharp, it is blurry. Second, it's slower. So for painting such a combo box arrow, you can as well disable alias painting and then just use something like this. So it's not only sharp, but it's faster than doing it like this. And usually this is what you want anyway. I will talk briefly about thumbnail preview. So in many applications you have like thousands of images, you don't see one by one, or you just flip through the images if you want to search for a particular image. Usually you just want to see all the thumbnails, and then you can pick the image that you want. So you hit the problem of scaling the image. Qt has two modes for scaling the image, either using the fast transformation or smooth transformation. So this is a big chessboard, and I scale it using fast transformation. This is smooth. You will not see the difference. That's why I zoom it. So on the left side it's like this, on the right side it's like this. So as you can see, this one is very fast but produce not so satisfactory result, while this one is better because it performs some sort of filtering. Now, what if we can have something like this, which is quite similar to this, but still 15 times faster? I call it cheap transformation. And the trick is, first from here, you have to move to, this is scaling process. So this is a big image. First you have to scale it to that image using fast transformation, and do another scaling to the target size with smooth transformation. This is performed twice, fast first and then smooth, but as you can see, the difference is not really noticeable. So this is some trick that you can use because it's 15 times faster, but the result is just approximately the same. There are also some important widget attributes if you want the painting to be fast, like static contents, opaque paint event, no system background, and so on. You can have a look at the Qt documentation for details. There are even dangerous widget attributes that you can use, although you must be careful if you use this. Paint on screen, native window, don't create native adjuster, and so on. Of course, if you have a look at the Qt Quarterly issue 16, you will see that since 4.1 we support backing store, which means that Qt tries to minimize the overdraw automatically for you. So you have to be careful that you don't do an overdraw, because Qt might have done some painting for you already. An important thing here is that since we are going to release Qt 4.5 soon, there's the Qt Falcon project, which is the code name for faster painting and rendering optimization in Qt 4.5. So if you want your application to be faster, then you can as well use Qt 4.5, which is yet to be released. For example, we have faster Raster engine, just doing a begin and end. With 4.5 is several times faster, as you can see from this graph. Red is using 4.5 and purple is using 4.4. And the widget repaint is also faster, as you can see from this benchmark result. And of course, before I mentioned that you have to use QGL widget if you want to accelerate, hardware accelerate your application. But with Qt 4.5, Qt even does it for you. So you just need to pass this option, dash graphic system OpenGL, when you launch your application, and all the painting will be done using OpenGL. You don't need to modify your application. You don't need to modify the code. And there are also some other improvements in 4.5, like backing store is much faster, so you will see less and less flickering. And we have new OpenGL ES2 paint engine, which is useful for embedded device. And for X11, we improved the paint engine performance by using the shared memory extensions if the X server supported. So there's no overhead when doing when transferring the pix map from the client to the server. Style sheet have been improved as well. And of course, like I said before, graphics view is usually a bit slow when you do a lot of clipping and scrolling. You have to play some tricks. And in 4.5, the QGraphics view will try to perform some optimization automatically for you. So I hope I've shown some examples, some real-life examples with the ideas and the techniques behind those examples. And of course, I hope that this talk will give you ideas and tricks and inspiration so that you can speed up and beautify your application. If you want to see more tips, then please follow the Qt Quarterly. There are some very nice articles there. Or follow our Trolltech Labs website where we post development news from time to time. Or just see the graphics dojo corner there. Every week usually there's a new graphics example. And of course you can also send email to us asking about anything that can be achieved with Qt graphics, and then we will try to put it as an example on graphics later. Thank you very much.